The Structure of Scientific Revolutions is Professor Thomas Kuhn's seminal work published in 1962 while he was based at Berkeley. It shows through a historical analysis how science develops and how important scientific discoveries are made. In the introduction, Kuhn tells us how he was influenced by other figures including Paul Feyerabend. He also tells us that he observed differences in the way the physical sciences and social sciences operated, and this gave him the idea for a paradigm. In Chapter 1, Kuhn introduces important concepts. He differentiates between normal science, which is about confirmation of established theory and puzzle solving, and revolutionary science, in which there is a fundamental change in the central theory. He also tells us about the illusion of science and progress. To think of science solely as a cumulative progression of knowledge is an illusion. He tells us that revolutions in science don't occur without a tension and conflict between the normal science and revolutionary science communities. In Chapter 2, The Route to Normal Science, Kuhn further distinguishes between normal and revolutionary science. He says that the textbook is central as it states the common problems encountered by a research community. He also says that establishing a research consensus is a very difficult process. Kuhn suggests two features of revolutionary science. Firstly, unprecedented findings which draw people away from other areas. This is very competitive. And secondly, that it is open-ended and that everyone can become a stakeholder. Kuhn discusses revolutionary science in branches of physics. He says that immediately after the revolution, the science language can be understood by those outside the community, but it quickly becomes specialised, and those that ignore it within the community are bred out of the profession. The community develops specialised equipment to investigate the central paradigm. Kuhn suggested that the social sciences at that time were undergoing a revolutionary paradigm shift, that medicine was driven by a strong external social need, that technology assisted in the development of science, and that astronomy arose in prehistory. In Chapter 3, Kuhn expands on normal science and discusses qualitative and quantitative issues. He describes normal science as establishing significant facts, relating facts to theory, and expanding upon theory. Kuhn relates paradigms to the social structures of the scientific community and how it solves the acute problems faced by that community. He also notes that the complexity of nature is being made to fit into the rigid structure of a paradigm. Kuhn suggests that scientists that don't work within a paradigm are generally ignored by the community unless they are part of revolutionary science. In Chapter 4, Kuhn looks at puzzle solving. He says that scientific communities solve puzzles, that they do so within a framework of rules, that they choose puzzles that are solvable, and that solutions must satisfy the surrounding framework of rules as well as solving the problem. The central paradigm is important. Kuhn notes that an amendment to Newton's inverse square law of gravitation was only accepted when it supported the central paradigm. In Chapter 5, The Priority of Paradigms, Kuhn writes that rules govern a research tradition, that scientists have a common understanding of this, but it is intuitive in much the same way as an understanding of games are, as described by Wittgenstein. Kuhn suggests that science has little coherence, as different branches of science are governed by different paradigms. In Anomaly in the Emergence of Scientific Discoveries, Kuhn demonstrates what a research paradigm is, with reference to the discovery of oxygen. He shows it as the result of the work of many scientists, culminating in the definitive statement by Thomas Priestley. Kuhn writes that normal science is about confirmation, which detects anomalies, which drives revolutionary science, which helps scientists see the world in a different way. He analogizes with a card game in which subjects only see a pattern if they have an underlying set of rules. Chapter 7, Crisis in the Emergence of Scientific Theories, Kuhn looks at several historical examples and notes that criticisms of Newtonian mechanics didn't go anywhere because there was no, quote, crisis in science, unquote, at that time. In Chapter 8, The Response to Crisis, Kuhn writes that, in criticising one theory, the scientist must propose an alternative, otherwise this is not the pursuit of science. He says that when the competitive process ends, the branch of science becomes static, and gives one example where it becomes a research tool. He says there's discrepancies even in the most successful of paradigms, that when there is a crisis, there are increasingly divergent explanations and a loss of identity within the field, and that all crises involve a blurring of paradigms. Crises are handled in three ways. In the first case, the crisis is handled. In the second, resistance to radical approaches arises. And in the third, the crisis leads to the emergence of a new candidate for paradigm. In Gestalt theory, the visual perspective is based on the sum of the parts. Kuhn says that paradigms operate in this way also. Kuhn suggests that in a crisis, the number of speculative theories increases, and that scientists involved in revolutionary science are deeply immersed in crisis and are either very young or new to the field. In Chapter 9, The Nature and Necessity of Scientific Revolutions, Kuhn draws parallels between scientific and political revolutions. He says that in both cases, communities with different values from the mainstream are unable to challenge within existing institutions and must separate out in order to do so. He is careful, however, to distinguish the two, as scientific revolutions are driven by anomalies. He also notes that the proponents of different paradigms are unable to hold joint discussions as they operate within different frameworks, with divergent views that cannot be resolved. Chapter 10, Revolutions as Changes of Worldview, is one of the lengthiest chapters and revisits some of the earlier points about Gestalt. After a revolution, science students must be trained in a new way. John Dalton was a meteorologist rather than a chemist, and yet he developed atomic theory. Kuhn uses his example to demonstrate principles about paradigm shifts, in which common assumptions are abandoned, there is debate between highly regarded proponents of different perspectives, and a significant proportion of the scientific community are persuaded of the advantages of the new paradigm. In Chapter 11, The Invisibility of Revolutions, Kuhn suggests that textbooks are rewritten after revolutions and that the historical context is assumed to be unimportant. As a result, there is historic revisionism, which obscures the nature of revolutions. The rewriting follows a pattern, with a central problem being posed before the paradigm change, and key scientists described in relation to the solving of this in an iterative fashion. All other problems vanish. In Chapter 12, The Resolution of Revolutions, Kuhn suggests that normal scientists and revolutionary scientists differ from each other, and that revolutionary scientists are able to challenge the paradigm. He categorizes theory validation as categorical or probabilistic. Categorical models explain all experimental findings, and the more realistic probabilistic models account for most of them. Theory validation occurs by identification of evidence for the theory, or, as per Karl Popper, falsification. In Chapter 13, Progress Through Revolutions, Kuhn suggests that the scientific community gains identity by agreeing on past and present accomplishments, that science doesn't move towards any goal, that normal and revolutionary science are cycles necessary for knowledge, and asks what must the world be like for us to know it. The Postscript was written 7 years after the book was published, and like the book itself, is difficult to summarise. Kuhn reflects on the criticisms of his text, explains that paradigm has different meanings, that scientific communities have received standardized training and unanimous professional opinion, and that there was no physics community before the mid-19th century, when it was an intersection between philosophy and mathematics. Kuhn describes the transition in paradigm changes, that revolutions are a renegotiation of relationships within a community, crises can be generated from outside the group, and explains it in terms of a disciplinary matrix. Kuhn notes that incommensurability is a function of the scientific community, that the puzzle is a group-licensed way of seeing the world, that consistency is an integral value for the scientific community, and that historical analysis is necessary to contextualize scientific progress. Final points. Read the book, a summary won't suffice. Engage with it, try and bring an understanding of your branch of science to the book, maybe leave some comments on the channel, start a conversation, and try and bring some knowledge of the book into your branch of science, that two-way flow. I've written a more detailed review with and without music on the background. The videos are on this channel. I've written a review on the blog. I've developed an interpretation of scientific revolutions, again on my blog, and also written a review of Against Methods, which is also a video on this channel. Hope you enjoyed. Thanks for listening.